Assalamu alaikum wa rahmatullah. Today we'll study lesson 2, unit 4, part number 2. This lesson is position of a circle with respect to another one. Let's start. We studied before that we have 4 positions of a point with respect to a circle and also 4 positions of straight line with respect to a circle. Now, how many positions of a circle with respect to another one? Let's see. We have 6 positions. Number 1, distant circles. Distant circles. Number 2, touching externally. The 2 circles are touching externally. Number 3, the 2 circles intersecting. Number 4, the 2 circles are touching internally. Number 5, the 2 circles, one of them inside the other. The last position is concentric circles. What's the meaning of concentric? That means the 2 circles have the same center. Now, let's start the property of each position. Now, the property of the first position. Here I have 2 circles, M and N. Okay, and I want to determine the position between them. To determine the position of the 2 circles, we will compare between the length of MN, the length of a line of centers, and sum or difference of 2 radii. As we can see here, MN equals MN greater than the sum of R1 plus R2. Then the 2 circles here, M and N, are distant. There is no intersecting between them. So Mn, the length of Mn, belong to interval sum of the 2 radii and infinite. Now, how many common tangent in this case? Let's see. This is the first one, and this second, 3 and 4 common tangents. Then we have 4 common tangent in this case. Okay, the second position. The 2 circles M and N. Now, as we can see here, Mn equals the sum of the 2 radii. Then, if Mn equals R1 plus R2, that means circle N intersect circle M at one point A. Therefore, circle N and circle M touching each other externally. And straight line L which passing through point A is called common tangent. And this straight line L is perpendicular to the line of centers, perpendicular to Mn. Okay, now how many common tangents in this case? Let's see. The first one, straight line L, and this the second one, and this the third one. So we have 3 common tangents in this case. When the 2 circles touching externally, that means we have 3 common tangent in this case. The third position. I have two circles M and N, and the two circles, as we can see here, intersect at 2 points. Look at the length of MN, the line of centers. MN here is greater than the difference of the two radii and less than the sum of two radii. So this case is called two circles are intersecting. M and X are two circles intersecting, okay? And the two circles intersect at 2 points in X and Y. The line segment XY is called common chord. Common chord. Chord in circle N and in the same time chord in circle N. So XY is called common chord. Look at MN and XY. MN here, the line of centers is perpendicular to the common chord XY. And also MN straight line bisect the common chord XY. And MN straight line is axis of symmetry of XY. So, in this case, MN belongs to interval, the difference between two radii and the sum of two radii. Now, how many common tangent here? This is the first one, and this the second. So we have two common tangent in this case. In intersecting circles, we have two common tangent. Position number 4. Here we have two circles M and N. And as we can see here, MN, the length of MN equals the difference between the two radii, R2 minus R1. When the length of MN equals R2 minus R1, the difference between the two radii, therefore the two circles here are called touching internally, okay? Touching internally. The two circles intersect at one point, point A, and the straight line L, which passing through point A, is called common tangent of the two circles, tangent of circle N, and in the same case, tangent of circle M. So L, straight line L, is called common tangent of the two circles. And straight line L perpendicular to MN. How many common tangents here? One common tangent. Position number 5. If circle N moves inside the circle N, as we can see here, the length of MN is less than the difference between the two radii, MN less than R2 minus R1. So, circle N intersects circle M equals phi. There is no intersection between them. That means this case is called circle N inside circle M. One inside other. Are there any common tangent here? Of course, there is no common tangent in this case. Number 6. The last position. If circle N moves inside circle M when center N lies on center M. So the two circles here are called concentric. Concentric means the length of MN, the length of the line of centers equals 0. So the two circles are called concentric. That means they have the same center. Okay, circle N intersects circle M equals phi. There is no intersection between them. That means circle N and circle M are concentric. And also in this case, there is no common tangent between them. Now, drill number 1. Here I have two circles, M and N, with radii length of 9 cm and 4 cm respectively. Show the position of each of them respect to the other in each of the following case. Now, firstly, if I want to determine the position of two circles with respect to the other, that means I will compare between the length of MN, the length of line of centers, with difference between two radii or sum between two radii. So I will compare between the length of MN and 5 or 13 centimeter. If MN greater than 13, that means the two circles distant. If the MN equals 13 centimeter equals the sum of two radii, then touching externally. But if the length of MN equals 5 equals the difference between the two radii, therefore the two circles are touching internally, but the length in between 5 and 13, MN equals in between the 5 or 13 centimeter, that means the two circles intersecting. Okay, when MN less than 5, less than the difference one inside other, and if MN equals 0, that means the two circles are concentric. Let's see. MN here equals 13 equals the sum, then the two circles touching externally. Number B, if MN equals 5 centimeter, then MN here equals the difference, therefore the two circles touching internally. What about C? If MN equals 3 is less than the difference, yes, one inside other. Number D, if MN equals 0, that means the two circles are concentric. Number E, MN equals 10. That means the length of MN in between difference and sum. Therefore, the two circles are intersecting. Again, if the length of line of centers MN in between difference and sum, the two circles are intersecting. The last one, if MN equals 15, MN greater than the sum, that means the two circles distant. The two circles are distant. Now drill number 2. Complete in each of the following figures. Number A. Here I have two circles, M and N, touching internally, and AB straight line is a common tangent of the two circles at point A, and he asked me to find the measure of angle BMN. Again, he asked me to find the measure of angle BMN. Okay, this angle. Now, we studied before that if the two circles touching internally, that means MN perpendicular to the common tangent AB. So this angle MAB equals 90 degrees. In the triangle MAB, measure angle A equals 90, measure angle B equals 40. Therefore, measure angle BMN equals 50 degrees. Now, number B. Also, I have two circles intersecting internally. Okay, and the length of MN, the length of line of centers equals 5. The length of MC equals 3, and he asked me to find B, the length of BC. The length of BC. BC here part of R1, part of the radius of circle M. How to find this part? Firstly, the two circles intersecting internally, touching internally. That means the length of MN equals the difference between two radii, the difference between R2 minus R1. But R1 here equals 4 centimeter. Why? Because this triangle NCM is right angle triangle at C. Why? Because NC is a radius and MB is a tangent of circle N. That means this angle equals 90. So the length of NC equals 4 centimeter by using Pythagoras theorem. Then R1 equals 4 centimeter. So 5, the length of MN equals R2 minus R1. 5 equals R2 minus 4. Okay, that means the length of MB, the length of R1 equals 9. So BC equals 9 minus 3 equals 6 centimeter. Okay. Number C. Here I have 3 circles, circle M, circle D, and circle N. Each two of them touching externally. The radius of circle D equals 1 centimeter, the radius of circle N equals 2 centimeters, the radius of circle M equals 3 centimeters. And he asked me to find the measure of angle DMDN. Again, the measure of angle MDN, this angle. Okay, to find the measure of this angle, I need to find the length of the 3 sides of the triangle to determine the measure of angle D. Now, the length of DM equals the sum of 2 radii of circle D and circle M. Radius of circle M equals 3 centimeter and radius of circle D equals 1. Then DM equals 4 centimeter. And DN equals 1 plus radius of circle N. 1 plus 2. So DN equals 3 centimeter. What about MN? MN equals 2 plus the radius of circle M. 2 plus 3. So the 3 sides are 4 centimeter, 3 centimeter, and 5 centimeter. So measure angle D equals 90 degrees. Example number 1. In the opposite figure, M and N are two intersecting circles at A and B. AB intersect MN at point D. X is the midpoint of YE. Measure angle XMN equals 3L minus 8. Find with steps the value of L. Here, the measure of angle M, XMD, is 3L minus 8. And he asked to find the value of L in this expression. How to find the value of L with this expression? If I know the measure of angle M, so I will solve the measure with this expression, so I will find the value of L. Now, here I have two circles intersecting. AB is a common chord and MN perpendicular to this chord. The line of centers perpendicular to the common chord. Then measure angle ADM equals 90. look at point X. Point X here is midpoint of the chord YE in circle M. So MX perpendicular to this chord. Now I have quadrilateral CXMD, and I have the measure of three angles of them, 90, 90, and 52. So I can find the fourth angle, the measure of fourth angle, 360 minus 90 plus 90 plus 52. Now look at the steps. The proof. Since circle M and circle N are two intersecting circles at A and B, therefore MN perpendicular to AB and measure angle ADM equals 90. In circle M, X is a midpoint of YE. Therefore, MX perpendicular to YE, therefore measure angle MXY equals 90 degrees. Now, in the quadrilateral XMDC, measure angle XMD equals 360 minus 90 plus 90 plus 52 equals 125. Now, 3L minus 8 equals 125. Therefore, 3L equals 136 and L equals 45.33. Now, thank you for watching. See you later in a new lesson. Thank you and goodbye.